So it is Tuesday, October 27th, 2020. Today we will be working with defining normal distributions / curves, drawing normal curves, and the 68, 95, 99.7 rule. And that'll be the focus of our day, or at least for the lesson. All right. So first, the normal distribution. We briefly touched on what this was on Thursday last week. The mean, mu, and the standard deviation, sigma, completely determine the shape of a normal curve. So if we have the mean and the standard deviation for something we've been told is normal, or is a normal distribution, we can draw it, essentially. That's what it means. It completely determines the shape. Mu, the mean, can be easily seen as the center of the peak of the curve. Sigma, or the distance from the center of one standard deviation, can be seen in the curve as the points at which the change of curvature on a normal curve takes place. You can also call these inflection points. This is only true for normal distributions. If I know the mean and the standard deviation of something that is not normal, is not a normal distribution, then I need more information to draw it. Oops, it easy. Last class too. All right. So this is kind of our setup to our formal definition. This is some of the things that we saw last week, just in a quick snapshot. All right. Can you raise your hand if you would like another moment to write this down in your notes? Excellent. Too quick. All right. Looks like we're ready. So then we have our formal definition from the text. All right. A normal distribution is described by a normal density curve. Any particular normal distribution is completely specified by two numbers. Its mean, mu, and standard deviation, sigma. The mean of a normal distribution is at the center of the symmetric normal curve. The standard deviation is the distance from the center of the change of curvature points on either side. We abbreviate the normal distribution with mean, mu, and standard deviation, sigma, as n parentheses mu comma sigma, close parentheses. Okay, so this is a new notation that when you see that, that means that, however it's been provided to you, they're saying that this is a normal distribution that can be described using the mean and standard deviation provided. Okay, they've given you enough information to draw a picture and then say things about it, just by giving you that notation. So a lot of what's in this top part of the definition here is kind of what I said on the previous slide. You've seen that type of information. The new thing that is very important is the notation that's been introduced. That capital N parentheses mu comma sigma. When we see that, it tells us something very specific. We have a normal distribution with a mean, some number provided, and a standard deviation provided. Okay. If you need a moment to write this down, please raise your hand. All right, looks like we're good. All right, so why do we care? Why is the normal distribution important? Well, they're good descriptors for some distributions of real data. They actually model things that happen in real life, which is nice, such as scores on tests taken by many people, like the SAT or IQ tests. If we combine all of that data and put it into like a histogram or dot plot or something of that nature, it would approximately be a normal distribution. So we can use that normal curve, right, and that kind of drawing to make conclusions about it and to say things about it because it's close enough to being normal. We can see normal distributions in repeated careful measurements of the same quantity, like the diameter of a tennis ball. So you want the diameter of a tennis ball to be basically the same from one tennis ball to the next. There can be a small amount of variation, and the variance from the average diameter of a tennis ball, right, creates a normal distribution. We have characteristics of biological populations, like the lengths of crickets or yields of corn. Again, things that have kind of a standard range, if you will, of like smallest value and largest value in populations kind of fall into these normal distributions. Right? A majority of the data is going to be in the middle, and you have it kind of taper down on both sides as a bell curve. All right. Normal distributions provide a good approximation of the results of many chance outcomes. An example would be the number of heads in many tosses of a fair coin. And so what this means is, like, if I had everyone in the class flip a fair coin 20 times, and we recorded how many heads we had out of our 20 flips, and we plotted all that on a graph as like a histogram or a dot plot, it would look like a normal distribution. It would have that kind of bell curve. Right. And lastly, many statistical inference procedures are based on normal distributions. We'll get into that later. That is not a topic for today. However, how we make inferences, some of that is based on normal distributions and the expectation of where values will lie based on a normal distribution. Can you raise your hand if you'd like a little more time to write any of this down? All right. No hands. All right, so now we're going to get to the steps on how to draw a normal curve. All right, so if we're being provided, right, our n parentheses mu sigma, we have enough information to draw the curve of that normal distribution. These are the steps we can follow. Number one, draw a number line with 7 evenly spaced tick marks. Label the one in the middle with the value of mu, the mean, and those to each side with mu plus or minus sigma, mu plus or minus 2 sigma, and mu plus or minus 3 sigma. Right? And so that means, like, to the right of mu, you'll add 1 sigma, 2 standard deviations, 3 standard deviations. To the left of mu, you subtract 1 standard deviation, 2 standard deviations, 3 standard deviations. Draw a dot above the mean where the peak of the curve will be. Step 3, above the marks 1 standard deviation from the mean, draw dots about 60% as high as the dot above the mean. Above the marks 2 standard deviations from the mean, draw dots about 15% as high as the dot above the mean, or about a quarter as high as the dots above 1 standard deviation. Step 5, above the marks 3 standard deviations from the mean, draw dots just above the horizontal axis. You just need to be just up above the line. And 6, connect the 7 dots with a smooth curve as best as you can. So if we follow these steps, we can draw a normal curve based on a provided mu and sigma. Okay. And we're going to go through these steps here on the next slide. Can you raise your hand if you're writing these down and need more time? All right. So let's draw a normal curve. Hopefully this turns out all right. So step 1, we need to draw a straight line as best as we can. All right. And we need to put 7 tick marks on it. We'll go start with 1 in the middle. We need to go 3 to the right. 3 to the left. Seems reasonable. All right, so the middle, right? That is where mu will be. To the right, we have mu plus sigma, mu plus 2 sigma, mu plus 3 sigma. To the left, mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. All right, and so this again would be based on being provided the notation, right, that we have a normal distribution, the mean of mu, standard deviation of sigma. All right, and so now we make our points. So we'll pick a point above mu, right? We'll just give it a height. Right. We don't know exactly what these numbers are. We're just doing a general case where we're just using the notation to draw this. If I had numbers, right, I would use a little bit of like, some like logic reasoning to decide how tall or short to make it, depending on how spread out it is. Right, the more spread out our data is, or the more varied it is, the larger sigma is, the squattier the graph gets, the shorter it gets. Right, the smaller sigma is, the more narrow the graph gets, taller that point is above mu. Right, so we have our point here, it's just right down the middle. Right, so this is just the middle. Now we go over to 1 standard deviation to the right of mu, right, mu plus sigma. And like about halfway up is here, so we'll go a little more. Right, and we'll come across and put a point directly across from that where mu minus sigma is. Okay, so we've got our 2 points here. And mu. Now, we go to the right 2 standard deviations, which is 15% of the height of wherever we plotted for mu, or a quarter of the height for whatever we plotted for mu plus sigma. It might be a little easier to be like, okay, well, about halfway is right here, so a quarter. And we'll draw our point that way. Same thing over here. Try to follow this across. We have about half, quarter, be close, right about there. So we've got our points here. The last point is just like, okay, put it just above the axis, right above our horizontal axis here. There's no like this percentage or this amount above or below a point. It's just put it slightly above. So now we have 7 points along our horizontal axis here, representing 1, 2, and 3 standard deviations away from the mean. So now we draw the curve as best as we can. All right. So essentially, it's going to start. I'm going to start on the left-hand side here. We're just going to try and go up through our points. As best as we can. And it's going to bottom out over here somewhere. All right. Obviously, it's not perfect. It's okay. This is a basic idea of how we can draw the normal curve using a provided mean and standard deviation. Right. What questions do you have, or is there anything I can clarify or re-demonstrate about how to draw a normal curve? Okay. Okay, we need another moment on this screen to draw the picture or write anything else down. So now, this brings us to our 68, 95, 99.7 rule. Right? In some textbooks, this is called the empirical rule. Right, so we're going to look at a graph that we saw last week. Right? We were looking at this ITBS vocabulary scores. Right? We have that is the curve here. Right? And it is a symmetric, single-peaked, and bell-shaped curve based on these vocabulary scores. Right? We're going to suppose the distribution of scores is exactly normal with a mean mu equals 6.84. That's our middle value. And standard deviation sigma equals 1.55. So from here to here, right? Right, the distance, right, of sigma here is 1.55. Right. Again, if we go from here to here, another 1.55. Right, and so on. Each sigma is the same value. The figure to the right shows the normal density curve for the distribution with the points 1, 2, and 3 standard deviations from the mean. That's what I have labeled across the top. Right, we have the mean up at the top, and then we have 1 positive standard deviation, 2 standard deviation, 3 standard deviation, less 1 standard deviation, 2, and 3 standard deviations. So that's what our picture is showing here. Right. We'll get back to this example in a moment. First, we're going to define the 68, 95, 99.7 rule right here. This is our definition along with the picture. Right. In a normal distribution with mean mu and standard deviation sigma, approximately 68% of the observations fall within sigma of the mean mu, right? 1 standard deviation of the mean. That's what's represented here. This area under the curve has 68% of our data, right here in the middle. Approximately 95% of the observations fall within 2 standard deviations of the mean. So now we go from -2 to +2 standard deviations. This area under the curve represents 95% of our data. Okay. And then approximately 99.7% of the observations fall within 3 standard deviations of the mean. Now we're at these last bars here, -3 to +3. Between here and here, the area of the curve, under the curve here, represents 99.7% of our observations. Right, this little bit to the tail, to the right of the 3 and to the left of the -3, that's the last 0.3% outside there somewhere. Okay. I definitely recommend having this picture as a reference in your notes or somewhere that you have access to. If you need a moment to write this down or draw the picture, please raise your hand. All right, so we're ready. So here's our example. Again, we have our ITBS vocab scores represented in this normal curve. And our notation here that is new, the n, parentheses 6.84, comma 1.55. Once again, this first number written here in our, we call this an ordered pair, right, is mu, right? This is our mean. The 1.55 is the standard deviation. All right. And so we want to know what percent of the ITBS vocab scores are less than 3.74. All right, we have 3.74 right here. It is 2 standard deviations to the left of the mean. Okay. But I want to know what is the amount or the area proportion under the curve that is less than 3.74. So I'm looking at this area here. What is this proportion of my data? Right now, in our 68, 95, 99.7 rule, it doesn't tell us what that percentage is. So we have to use some like deductive reasoning here to get to what the percentage is. So here's what we can do. I know that between the 2 standard deviations, right? The area under the curve between minus 2 deviations and plus 2 deviations is 95%. So I mean, 95% of my data lives right there in the middle between 2 standard deviations of the mean. That means that I have 5% of my data between the 2 sides, right? So if I have the other side over here that that's not part of the 95%, right? And the green area that I want is also part of the 5%, but not the 95. This is symmetric, which means that that 5% must be split evenly between those 2 sides. So I have over here on the left side, there's from the area that I've shaded here is 2.5%. And then on the other side, on the red, we have the other 2.5%. And that altogether adds up to the 100% of the area under the curve. So that means that I have 2.5% of the vocab scores are less than 3.74. And essentially the math that we did, if we want to look at the calculation, is we said, okay, well, I have 100% minus the 95% that I know is not included in what I'm looking at, will leave me what's outside of that area. And half of that, divided by 2, is the area that I'm looking at. Right, so we get 5% divided by 2, and we get our 2.5%. Okay, so this is our percentage of scores less than 3.74. What can I clarify here? Okay. All right, so then on question 2, what percent of the scores are between 5.29 and 9.94? Okay, so we're over here. And over here, these are my 2 numbers I'm looking at, right? 5.29 and 9.94. What percentage of my data is under the curve here? Looking at this whole space. And all the way down. Okay. So we're looking at this whole area under the curve. Does this area include all of that 95%? The answer is no, it doesn't. All right, so this has all of my 68%, right? It's got all of the one standard deviation of the mean. And then only half of that other part of the standard deviation, right? So we need to figure out how much is in this other part. Right? I know from here to here, I have 68%. Right? And that's based on that rule. Within one standard deviation, I have 68% of my data. Then I have 95% within 2, but I'm missing part of that 95%. So I have to subtract the part that's not included from the total that I'm trying to find. Okay, so I have 68%. I need to add this other section, right? That I need to add this part in to my 68%. So to do that, I find out how much the extra standard deviation is worth percentage-wise, which means I'll take the 95%, subtract the 68%, and divide that by 2. And that'll tell me how much one of these sections is worth percentage-wise. So I get 68% plus, this ends up 95 minus 68 is 27. 27 divided by 2 is 13.5. Right, and that leaves me with 81.5%. So that means, right, that under the curve here, I have 81.5% of my data is between 5.29 and 9.94. So again, I'm using the defined amounts, the 68, 95, 99.7, and then some like reasoning and a little bit of math to figure out the percentages in the given portions. Right, what questions do you have? How can I help? What can I just clarify? No questions? Right. Does anyone need me to go back to a previous slide or anywhere else within the presentation? Okay. All right, well, I'm going to end the slideshow here. And we're going to take a look at our week. All right, so we're on week 10, guys. We have stuff for today here. So we're in section 2.2. Live class resources. We'll have the notes. I'll post those in here shortly. And then I'll upload the recording once it's ready from today's lesson. There are a couple of AP Daily videos dealing with normal distribution. And, you know, like we have percentiles, the value of a given proportion, kind of like what we did today. Here's the area of the book that you can find this stuff in as well, from pages 103 to 112, if you'd like to do that. We have a digital textbook here in the resources. And our discussion board for today is about the 68, 95, 99.7 rule. So it is very similar to the problem that I just did with you guys in the notes. You'll be given a normal curve or a normal distribution based on the n parentheses mean and standard deviation. And you need to sketch a picture of that and then use that picture to determine the proportion of the data within certain endpoints and stuff, just like we did today. Right, and then there'll be a discussion board after Thursday's class that I am not going to make available quite yet because we need to learn how to use table A, which we haven't done yet. And I'm still figuring out what I'm going to do for the CYU this week, so that's not quite available yet. Right, so that's what our week looks like. Does anyone have any questions, comments, concerns?